Hi, my name is Julian Dragos and I work for Typesafe. I am also a committer in the Scala IDE for Eclipse project. In this screencast, I will walk you through the main features of the Scala IDE. We'll begin by looking at the features of the Scala Editor. We'll continue by showing you how to add and run your unit tests. We'll then look at navigating through your sources and finish with a look at how to run and debug your application. I have opened a fresh workspace containing an example application. The Scala perspective is very similar to the default Java perspective. On the left side of the screen, you see the Project Explorer and our address book application. On the right side is the outline view, which shows the structure of the open source file. At the bottom, you see the Problems view, containing any compilation errors you had for your last build. Let's start by opening the project and navigating to a source file. I'll begin by adding a toString method to the person class. Notice that as I am typing, the editor shows the errors in my code using red squiggly underlines. If I hover the mouse on the side, I will see the error message. The Problems view is still empty because by default the project is built only when I save the current file. Notice that after saving, the project is built and the same error appears now in the Problems view, below my editor. If I double-click on the error, it takes me to the corresponding position in the source. Let's use a formatted string to implement toString. When I type a dot or I press Ctrl space, I invoke the content assistant. Here I see all the members that I can call on the type string, including the members added by implicit conversions, such as format. We can see that format is defined in the class string like. After I save the file, the error is gone and I can proceed to the next step. Let's add a unit test to this project. First, I need to add the JUnit library to the Java build path. To do that, I go to the project properties and select Java build path. On the Libraries tab, I see all the libraries that are on my class path. Right now, I only have the Java and Scala standard libraries. Let's add the JUnit library. There are several ways to add the library to the class path depending on where it comes from. I can add libraries either as jar files in my workspace, external jars located somewhere else on disk, or a library shipped with Eclipse. For JUnit, I will choose Add Library and go for the JUnit 4 library. Notice that JUnit appears now under my project below the JRE library. Notice that the project is rebuilt since the class path has changed. Let's now add a test class. My project organizes source folders using the standard convention of keeping main and test sources separate. I right-click on the test source folder and choose Add Scala class. There are wizards for the most common Scala definitions such as trait, object, or package object, but this time I will choose Scala class. I will add my test in the same package as the application class's address book and give a name to my class. Once I'm done, I click Finish and the editor opens with a skeleton class definition. In this test, I will load an address book from a file and search for a name. I will use the address book object defined in my project and call FromFile. I haven't imported a Java IO file type yet, so the editor shows me the error. I love shortcuts, so along the way I will mention the ones I use the most. I can navigate to the next error in my source by typing Ctrl dot. This is a very useful one. Then I can press F2 to see the current error message in an overlaid window. Notice the little light bulb on the left gutter. The editor notifies me that I have a quick fix available. It found a file type on my class path and it can automatically add the import for me. Ctrl 1 applies the quick fix and the error is gone. Let's search for all persons named Williams and extract the first name. Notice that Content Assist works even under the placeholder parameter, the underscore in the call to map. The type inferencer realized that we are mapping a list of persons and I can choose the first name field. Let's now extract this result to a local variable. I can use structured selection. When I press Ctrl-Shift-Up and down, the editor increases or decreases the selection intelligently based on the nesting of expressions. When I have the desired expression, I press Ctrl-Alt-L to extract the expression to a local. I can now hover the mouse on an identifier and see its type. This works on any expression, not just local variables. Let's now rename the local variable. This time I will choose the rename refactoring from the menu instead of using a shortcut. Let's finish by adding an assert call and annotate the test method to make it a proper JUnit test. Notice that I can keep typing while content assist is open and even use camel case matches such as AT when looking for assert that. I'm using QuickFix all the time to add the required imports. Once I am done, I can use Organize Imports, Ctrl-Shift-O, to group imports by package. Now I am ready to run the test. Right-click on the source file and choose Run as JUnit test. The output is shown in the console window at the bottom of the screen. The JUnit runner window is on the left side, and I notice that the test failed. If I double-click on the failed test, the editor reveals the line that failed. Let's fix the test. Once I run them again, they pass. Let's now look at the definition of address book. If I hold down the Control key and I move the mouse over an identifier, I can hyperlink to its definition. The address book file opens. To navigate inside the file, I can use the Quick Outline, Ctrl-O. The Quick Outline shows a list of all definitions in the current file. I can navigate to any member and even search incrementally for a definition. Hyperlinking works also for definitions in dependent libraries as long as they come with attached sources. So let's hyperlink to the definition of array buffer. Another useful shortcut is F3, which hyperlinks to the definition under the cursor. I can continue to explore the standard library by hyperlinking. Also, the Quick Outline works in libraries as well. I can also start to navigate directly to a type. Ctrl-Shift-T brings up the Open Type dialog. Let's open genseek in the standard library. I'll close now all the open windows and wrap up with a short debugging session. Let's go back to the address book class. I can set a breakpoint by double-clicking on the left gutter. The simplest way to run my application is to right-click on the main source and choose Debug as Scala Application. This will launch my program in the debugger and automatically switch to the debug perspective when the breakpoint is hit. The debug perspective has a different organization from the usual Scala perspective. On the top, we have the current stack, showing where the debugger has stopped, together with shortcuts for stepping, resuming, or stopping execution. On the top right, I have all the local variables in scope. If I click on a variable, it is displayed in the Detail panel. I can use F6 to step over and execute one line of code. I can expand the address book object to see its members and their current values. At each step, new local variables that come into scope appear in the variables list. After one more step, the file is loaded and I can see the parsed entries in the address book object. Let's resume the application by pressing F8. No other breakpoint is hit and the application finishes execution. The output is shown in the console window at the bottom of the screen. To go back to editing, I reopen the Scala perspective by pressing Ctrl F8 or clicking on the Scala icon in the top right corner. This is the end of our tour of the Scala IDE for Eclipse. You have seen how to edit your sources, how to run your unit tests, how to navigate around your project, and how to debug your application. For a complete list of features, please visit www.scalaide.org. Thank you for watching and I wish you happy Scala coding!